here. X, Y. My vertex is 1, negative 6. Okay? Since there's no fractions in here, I'm going to go down 1, up 1. If I plug 0 in for x, 0 minus 1 is negative 1. The absolute value of negative 1 is 1. 2 times 1 is 2, minus 6 is negative 4. So if you were to put that in there, it's 2, absolute value of 0 minus 1, minus 6. The absolute value of negative 1 is 1. 2 times 1 is 2, minus 6, we get our negative 4. That's where the negative 4 is coming from. Then I'm plotting my points. I don't need to worry about vertical shrink or stretch on these. I don't need to worry about line of symmetry. I just got to get the graph down. 0, negative 4 is here. My vertex is 1, negative 6. 2, negative 4. 1, negative 6. 2, negative 4 is right here. So, it's a less than or equal to, so solid line. Now I plug that 0, 0 in. 0 is less than or equal to 2 times 0 minus 1 minus 6. 0 is less than or equal to 2 times negative 1 minus 6. The absolute value there is 1. So 2 times 1 is 2 minus 6. Is 0 less than or equal to negative 4? Is that true or false? Is 0 less than negative 4? That's false. If I have a false statement, I shade away from the 0, 0. Where's 0, 0? It's right here. So if that creates something false, here's how we shade on the outside. You don't need to color the whole thing in. If you want to verify, put a negative 10 in for y. Guess what is less than negative 4 when we put 0 in for negative 4? Negative 10. Negative 10 can confirm that. 0.0, negative 10 can confirm that you're right. But that's how you shade away when the 0, 0 is inside the graph, inside the V. Okay? Here, x, y, negative 2 and 8. I'm going to go with negative 4 and 0 because I want to count up and down by 2 here. I'll use 0 to put in. Negative 1 half, absolute value of 0 plus 2 plus 8. The absolute value of 2 is just 2. Negative 1 half times 2 is negative 1 plus 8. So it's 7. 0, 7, 1, 2, 3, 4, 5, 6, 7. Negative 2, 8. Negative 4, 7. This is a greater than, so it's a dotted line. 0, 0 is clearly inside the V. When I plug 0, 0 into the original, 0 is greater than negative 1 half. 0 plus 2, I'm going to try and skip here a little bit, is 2. The absolute value of 2 is 2. Plus 8. Is 0 greater than 7? No. 0 is not greater than 7. That's false. So we're shading away. And that's how we shade. Yes, ma'am. So my vertex here.
Hello?
1, negative 4. There's no fraction. 0 and 2.
No, I didn't.
When I plug 0 in, okay.
I have seen lunch, but can I do it after this one? Like just drop it off.
Okay.
Alright.
0 minus 1 squared minus 4.
Alright. No, I just asked. I forgot.
Negative 1 squared minus 4. Negative 1 squared is a positive 1. 2 minus 4, we get negative 2.
I'll explain it to you.
This is negative 2 as well. Okay. So 0, negative 2 right here.
Alright.
1, negative 4 here. 2, negative 2 right here. It's a solid line. And my 0, 0 is inside of it. Now when you plug 0 in for x, I already did it. Is 0 greater than negative 2? Is that a true statement? Yeah. So we're shading inside. Okay? The second one, don't leave with the bell range, just wait till I'm done. -2, 3. Fraction is 1/3, so I'm going to count down by 3, I'm going to count up by 3. -5 plus 2 is -3. And that's what I'm squaring. -1/3, -3 squared plus 3. -3 squared is 9. -1/3 times 3, or -1/3 times 9, I'm sorry, is -3 plus 3, so I get 0. And I get a 1, 0 there as well. Okay? So now when I go to graph this parabola, -2, 3, 1, 2, 3. -5, 0 is over here. 1, 0 is over here. It's a solid line because it's greater than or equal to. And the 0, 0 is inside. If I plug 0 in for x, we can do it down here. 0 is less than or equal to -1/3 times 2 squared plus 3. Now think about it. 2 squared is 4. 4 times the -1/3 is -4/3. -4/3 and 3 is a positive number. It actually ends up being 1 2/3. That's a false statement. And 0, 0 provides a spot inside the graph, we shade on the outside.